This video will provide an overview of the lessons for week 24, days 32 through 36. This week, students will finish their work on task 3, a water molecule's journey, then begin task 4, thermal energy transfer. First, students will connect their learning about how water cycles around the Earth to the culminating project for the unit. How does water affect the climate in their chosen region? Then, the following day, they will reflect on their learning to make connections to the cross-cutting concepts of systems and system models to wrap up task 3. On day 34, students will begin their work on task 4, beginning with a review of important concepts from Unit 1 about thermal energy transfer. Then, in preparation for designing their own independent experiments, students will learn to write a scientific hypothesis in the context of a familiar phenomenon with thermal energy transfer. Finally, on day 36, students will start planning their own controlled experiments to investigate and explain the factors that affect changes in temperature. Let's go through the key points from each day, starting with the lesson for day 32. Now that students have developed models for how water cycles around the Earth, they will connect their models to the culminating project for the unit. How does water affect the climate in their chosen region? Using words or a model, students will describe the processes that create the water conditions in their region. Check for student understanding by asking them about lake effect snow, a common weather phenomenon in the Great Lakes region. The presence of such large lakes has big effects on local weather patterns. A large surface area of water means lots of evaporation, which means more water vapor in the air, which leads to more precipitation. In the winter, that can mean huge snowfalls. However, if the surface of the lake freezes, that cuts off the process at the source, leading to less snow. On day 33, students will wrap up their work on task 3 with some reflection. Just as they did at the end of task 2, students will reflect on their learning during this task. First, they will add to the list they started at the beginning of task 3 by thinking of more ways that water is a part of different climates. Then, they can relate their learning back to the cross-cutting concept of energy and matter. Finally, they will generate questions about water, climate, or related topics. Be sure to give students a chance to share their ideas in a class discussion. The final wrap-up question for this lesson is another chance for students to connect their learning about water to the culminating project for the unit. They should think about what people do to survive in different climates with varying access to water. On day 34, students will begin task 4, in which they will study temperature and thermal energy transfer. You may recall that these topics were also covered back in Unit 1, Energy. However, students will now have an opportunity to apply their knowledge to the study of climate and the ways that humans adapt to their local climates. The main objective on day 34 is to review students' prior knowledge. A separate video available with day 34 goes into more depth with important definitions, common misconceptions, and forms of thermal energy transfer. The scenario for students to consider is one they may have experienced themselves at home. You leave a metal spoon in a pot of cooking pasta. Although the handle of the spoon may be above the surface of the water, when you touch the spoon after a minute, ouch! The spoon is super hot. This is due to conduction, a form of thermal energy transfer. First, the boiling hot water transfers thermal energy to the part of the spoon that's in the water. Then, the atoms or molecules in the spoon transfer thermal energy to each other, up the handle of the spoon until the entire spoon has much more energy and feels hot to the touch. To help students develop an explanation of what is happening in this scenario, first, show them the video embedded in slide 15 about conduction. After students have had an opportunity to think on their own, they can share their ideas in a class discussion. The next day, on day 35, students will continue to use this scenario to practice writing a scientific hypothesis. Why does the spoon get hot when it's left in boiling water? The video embedded in slide 14 provides a great overview of how to write a scientific hypothesis. The definition for hypothesis given in the video is a prediction with a reason. The video then provides a very helpful sentence frame for students to use when writing a hypothesis. If, then, because. The video also provides students with some examples of good and bad hypotheses, as well as a rating scale and explanation for students to use to assess the examples. For example, this hypothesis says, if I leave a gummy bear in water overnight, I think it will get bigger because it will absorb water. The video explains that this is a very good example because it provides a prediction of what will happen in the future, as well as a good reason for that prediction. Students will then write their own hypotheses for the spoon in hot water example. They should write their hypothesis on page 1 of the new student handout. One possible correct hypothesis for this example might be, if a metal spoon is placed in hot water, then the temperature of the spoon will increase because thermal energy is transferred from the hot water to the spoon, then through the particles of the spoon, aka conduction. As before, this lesson ends with a class discussion so that students can share their hypotheses. You could even have students use the rating scale from the video to assess each other's hypotheses or their own. Finally, this week, on day 36, students will begin planning their own controlled experiments to investigate changes in temperature. Begin by reviewing the definition of temperature. Temperature is the average kinetic energy in a substance or system. In this photo, the temperature of the water is much lower than the temperature of the person because the particles that make up the person have more energy on average than the water's particles. Be on the lookout for students who confuse temperature with heat or thermal energy. Introduce students to the planning phase of their controlled experiments. The goal of the experiment is to discover factors that affect changes in an object's temperature. There are many possible experiments for students to perform using simple objects that they have available at home. Before deciding on an experiment, students should first determine what materials they have available to them. This may vary greatly from student to student. On page 2 of the student handout, students should develop their experimental question, then identify the independent and dependent variables in their experiment, as well as the controlled variables they will need to account for. Finally, they will list all the materials they need for their experiment. Another video attached to the lesson for day 36 provides examples of and suggestions for possible experiments that students can plan, as well as a more in-depth discussion of experimental variables. Remember, each lesson slide deck comes with a cover slide with links to Google Docs and other materials. The following slides provide helpful content background information, suggestions for teaching synchronously or asynchronously, language development supports, and supports for ELs and students with disabilities. Those are the major tasks and key points for week 24, as students complete task 3, a water molecule's journey, and begin task 4, thermal energy transfer.